Hi guys, this is the video for chapter 6, lesson 4. So in this lesson, we are actually going to only take a look at this first half of lesson 4. And we are not going to look at the back of the study guide just yet. We might look at that later on, but not today. So what we're going to take a look at today is taking a look at proportional relationships. So a proportion is really just comparing two rates or two ratios and making sure they have the same value, okay? So if I were to say you need a half cup of sugar to make this recipe or whatever, or let's see, not half cup of sugar, but 1:2 ratio of um, 1 cup of sugar to 2 cups of flour, let's say. So we'll say this is sugar to flour. And I wanted to double this recipe. Well, my ratio should still be in the same proportions, right? I would probably do 2 cups of sugar to 4 cups of flour. So you actually use proportions a lot in baking because if you were doubling or tripling a recipe, you want to keep the ratio between your ingredients the same. If you all of a sudden do 2 cups of sugar, but you don't change your flour and it stays the same, then you're not going to come out with the right consistency of food. And so with looking at proportions, really what that's saying is your rates are the same. So if I simplified this, one easy way to check to see if the rates are the same is to simplify them. So if I simplify this, well, this one's already simplified, it's 1/2. 2/4 simplified is 1/2 as well. And so the rate when it's been reduced and simplified will be the same. And that's really how we decide if the ratios that we're looking at are proportional, because when we reduce them we can see that they're the same. So if when we reduce proportions they are not the same, then they're not proportional. So let's take a look at this example here. We're looking at a rate of time to distance. So there's a chart here that says per 1 minute 300 yards are traveled. Per 2 minutes, 600 yards are traveled. 3 minutes, 900. 4 minutes, 1,200 yards, okay? So we can actually turn these all into fractions, and they did that in the study guide. Turn them all into fractions and then simplify. And when we simplify, we realize they all reduce to 1 out of 300. Okay, 1 out of 300. So then our rates here are all equal. They're simplified and equal. And so we're going to say that these sets of numbers, the time to distance, is proportional. Looking down below, same thing. We're turning these values as a fraction comparing jumping jacks and time. So we've got a bunch of fractions reduced, fraction reduced, fraction reduced, fraction reduced. And we're comparing all of them. Well, these first two are the same, but then these two aren't the same anymore. So the number of jumping jacks is not proportional to the time because it's not consistently the same. So that's all you have to do for this lesson is decide if the rates are proportional, the numbers are proportional. And if they are, you're going to say they are proportional. You're going to explain why. It's because the rates are equal. And if they're not proportional, you're going to explain that they're not proportional because, hopefully you're going to say because the rates are not equal. So we have to reduce that to find out. So you could write each reduced rate on the bottom if you want. Looking at number 1, this would be like 3/2. That's 3/2 reduced, divided by 3, right? Divided by 4 would be 3/2. Divided by 5 would be 3/2. So I think in this one, we would say that this is proportional. And we would say that the rates are equal, okay? Let's take a look at number 3. So number 3, if you look at this, this is miles to hours, 43 miles in 1 hour. Well, in this one, if I predict going up 1 to doubling this, where 2 hours, I should have double the amount of hours, which would be like 86. And this isn't 86, right? So I don't think this is proportional. And I don't even have to look any further because I just know that that's not proportional. So we're going to say it is non-proportional because the rates are not equal. And you can actually even check to see if the rates are equal or not by finding the unit rate. So number 2, like we've got some decimals here, we can do 1.3 divided by 2, 2.1 divided by 2. And when I divide that, I get 1.05. 1.3 divided by 1 is 1.3, right? 3.3 divided by 3 is 1.1, I believe, right? So 1.1. And so all of these, I don't even have to go any further. All of these rates are different. They're not the same. And so we're going to say it is not proportional or non-proportional. You can say either one. And you can explain that the rates are not equal, or you can show that the rates are not equal on your work. So I'm not going to do any more. I think you get the idea. On your homework, you're just doing these first 6 problems because this last one is over the back of the study guide, which we won't look at yet today. So basically, you're just doing these first 6. Number 5 and 6, you're predicting other amounts using the rates. And so you're filling out the rest of the chart. Now we're going to just take a look at the first half of 6.5, okay? So solving proportions. Now, like we said earlier, if we were solving if we were to look at 2 rates, 2 ratios, and decide if they have the same proportions, we can simplify them and decide if they're the same. So let's say I have 2/3. That is equivalent to 6/9, right? These are proportional rates. So I'm comparing these two and they are proportional. So I can say they're equal because if I simplify this, this will also be 2/3. So I'm saying that they're equal. Now, the big thing we're going to look at today is what if we actually don't know what part of my proportion is. I know that these two are equal, but I don't know this part. Well, yes, you could fill in the gaps in your head mentally and fill out, okay, it would be like 6/9. You could do that. However, sometimes it's not so simple, especially if you've got decimals in your fraction or the numbers are really big and you don't know what they are proportionally. You don't know what they are simplified as. So it can be kind of tricky. So we actually have a special trick to do this. What we realized is when I multiply diagonally across, I end up getting the same thing on both sides. So let's just double check to make sure this theory works first. I'm going to fill in the gaps. That would be 6/9. So if I multiply both sides across and set them up as equal to each other, so 3 times 6 and 2 times 9, are they going to be equal to each other? Well, 3 times 6 is 18. 2 times 9 is also 18. So yeah, it actually does work. And so we can use this method to help us figure out the unknown, which is really, really cool. And so let's act like we don't know the denominator is 9. And now let's talk about how we would do this. So with this, we would set this up as 2 times, well, I don't know what this is, 2 times an unknown. Let me give it a variable, 2 times x. E is equivalent to 3 times 6. So I can use algebra to actually help me solve. 2 times x equals 18. Now, when I want to get x by itself, I can divide both sides by 2, and x equals 9. And that's what we originally said it was going to be anyway. So x equals 9, which is true, and that works. So that's how we can solve. So looking at this example, they did the same thing. They multiplied diagonally across, multiplied diagonally across. 14.1 times 4 equals c times 3. Simplified this, divided by 3 on both sides, and got the answer as 18.8 equals c. So let's do one of these, and you guys can use your calculator. You can actually use your calculator for this entire chapter, so you don't even have to ask me every time. I mean, yeah, just go for it, especially with these big numbers and decimal numbers. So we're gonna do, we're gonna multiply across. We've got 8 times 12, and then 9 times 16. 9 times 16 here, 9 times 16 is equivalent to 12 times x. 9 times 16 is 144. 144 equals 12x. I can divide by 12 on both sides. I'm running out of room. And x equals 12. And so if you wanted to check, you could even simplify 12 over 9 and 16 over 12. You could simplify both of these, or even find the unit rate by dividing the numerator by the denominator. And if I divided 12 divided by 9, I get 1.3 repeating. And if I do 16 divided by 12, I also get 1.3 repeating. So these are equivalent. These are the unit rates, 1.3 repeating over 1, right? These would be the unit rates, and they're equivalent. So the rates are equal and they are proportional, and my answer is correct. So let's take a look at number 3, okay? Some bigger numbers. I'm going to multiply across and set them up as equal to each other. So I'm actually going to do it over here. 5 times 132 equals 60u. And so 132 times 5 is 660. 660 divided by 60 is 11. So divide by 60 on both sides, and we get 11 as our answer. And so u equals 11. Let's do 5, okay? So multiplying diagonally, if you start getting good at this, you might not even need to draw these arrows or circle them. 225 times 64, big number here, right? So when I multiply across, I have 14,400, put my comma in the wrong spot, and then equals, that's where the comma is, and then that equals 480a. So divide now by 480 on both sides, and you can plug that in your calculator, bring your a down, and it's divided by 480. So this is gone, let's divide by 480, and the answer is 30. Okay, so the answer is 30. Let's do one with a decimal. Let's do 16, and then I think that's all I'll do with you guys. You guys, it's pretty straightforward. You plug it all in your calculator, and because of that, it's probably a little less time consuming because you can just plug in those buttons. Okay, so 4.2 times 80 is 336 equals 4.8d. Divide by 4.8d, or 4.8 on both sides, divide by 4.8, and sorry, is it 70? The answer is 70. Did I do that right? Let me just double check. 336 divided by 4.8 is 70. Okay, so D equals 70. And if you want to check your answer, put 70 in place and then find the unit rate. So 70 divided by 80 is like 0.875, and then plug in 4.2 divided by 4.8 and see if you get the same decimal, which is also 0.875. So they have an equivalent rate, unit rate, and so these are proportional. Good, and that's all. We're going to finish up this lesson and do the back tomorrow, our next class. So all you need to do is 6 problems from this homework, and then we'll look at the rest of 6-5 on another day.